All right, we're going to do a couple more problems in this video for solving rational equations. So let's pop on down to problem E, and let's take a look at these denominators. We've got x squared, and we've got 5x. So first things first, domain restrictions. Let's go ahead and set each denominator equal to 0 and see what we get here. Well, let's see, 5x equals 0. Okay, so x equals 0, well, that one's already done. X squared equals 0, remember that's x times x. And if I set each of these factors equal to 0, that's already taken care of. And technically, it's a little weird to write it this way, but you can actually think of 5 as its own factor and set that equal to 0, and x is its own factor and set it equal to 0. That one just doesn't make any sense. So the domain restriction here, the only value that we have to worry about is x cannot equal 0. That's the only one that's going to matter. Now, part of the reason I wrote these out the way I did was to actually help me find my LCD, least common denominator. Remember, I want each factor that shows up. So I know I have an x. That will take care of this one, this denominator. Now, the x squared needs 2 x's, so x times x. So I need another x here. And then this 5x, well, I've got the x, but I'm missing the 5. So if I go ahead and put a 5 here, this whole thing is my LCD, 5 times x times x. So that's what I'm going to use to multiply with each of these fractions. So let me go ahead and zoom on in there. So what did I have? 5xx, and then another 5 times x, and another 5 times x times x. All right, let's do a little bit of cancellation here. So this denominator of x will take out one of the x's, so just make one of them go away. And we're going to have 1 times 5x minus this x squared will take out both of those x's, leaving behind the 5, so we're going to have minus 4 times 5. And then this denominator of 5x will clearly eliminate a 5 and an x. So 5 is gone and the x is gone, leaving behind 3 times x. So let's go ahead and distribute here. So 1 times 5x is 5x. 4 times 5 makes 20. Let's see, 3 times x, well, that's 3x. Let's solve this. So let's go ahead and subtract 5x from both sides. So negative 20 is equal to negative 2x. Divide both sides by negative 2. And I'm going to get x is equal to 10. Now, I'm pretty sure that was fine. And I'm zooming out so I can compare it. Yeah, x was equal to 0 was my domain restriction. So this is 10, totally fine. So my solution is x equals 10 with the domain restriction of x cannot equal 0. All right, let's go ahead and slide it over to part F here. Now, part F is going to be the first one that's a little bit weird in terms of we have this 1 sitting here, which is fine. There's no denominator, totally okay. That's not going to be an issue for us for the domain restrictions or the LCD, but it will be, you want to be careful with it when you are multiplying by the LCD. As far as the things that actually matter for domain restrictions, we've got x minus 5 and x squared minus 5x. So let's go ahead and take each one of those, set it equal to 0. So x minus 5 equals 0, x squared minus 5 equals 0. So if I solve this one, I'm going to get 5. I'm going to factor first here and then solve. So x equals 0, x minus 5 equals 0. And this one should look familiar because this factor right here was the original, was this first denominator. So my domain restrictions, let's see, x cannot equal 5 or 0. Those are bad values for these 3 fractions. So let's talk LCD. So my first term here, this first piece doesn't have a denominator other than 1, and multiplying by 1 doesn't change anything, so I'm not going to worry about this one. This denominator has the factor of x minus 5, so I want to make sure I include x minus 5. And this denominator, when I factor it, I'm going to slide over here, right? Here's my factored form. I have the x minus 5. That's already listed. I am missing the x. So let's go ahead and include an x with x minus 5, and that becomes my LCD that I want to multiply with. So I'm going to take this 1 times x minus 5. I'm going to take this fraction times x minus 5. And let's take this fraction times x minus 5. Let's see what I can cancel. Obviously, this doesn't even have a denominator. So I just want to write down 1 times what I've already got here. So 1 times x minus 5 minus the x minus 5s will cancel each other out. They divide each other out. So x times 3x minus 9 equals... Now, this x squared minus 5x, when we factor it, it is these two pieces, so that whole denominator will divide out the whole LCD, leaving behind just this original numerator of 2. Again, if you use the correct LCDs, when you do this step and you multiply by the LCDs, you shouldn't have any fractions anymore. It's kind of nice. Let's go ahead and distribute here. Let's see, 1x times x is x squared. 1x times negative 5x. Now, be careful that you're distributing out the negative here, so I want to make sure I distribute that in. So negative 3x squared plus 9x, that's going to equal 2. All right, let me combine some like terms here. So negative 2x squared plus 4x equals 2. Now, because this is negative, I'm going to go ahead and slide these two terms on the left over to the right. So I'm going to add 2x squared and then subtract 4x. So plus 2x squared minus 4x. So 0 equals, now I'm going to put this in descending order. Minus 4x plus 2. Now, I want to factor this. So I know I can factor out a 2. So let me go ahead and pull out a 2. So x squared minus 2x plus 1. I want to now factor this further. So what multiplies to positive 1 and adds up to negative 2? The only thing that's going to make that happen is if I do x minus 1 and x minus 1. Now that I've got it in factored form, I'm going to set each factor equal to 0. Even if it seems a little ridiculous. And yes, 2 equaling 0 is ridiculous, so no, that's not going to give me a valid answer. And I might also recognize that writing this equation, x minus 1 equals 0 twice, is a little ridiculous too. Because when I solve this, I'm going to get the same answer for both, which is x is equal to 1. So let's check and see if I can let x equal to 1 or if that's one of my domain restrictions. So domain restrictions were 5 and 0. Clearly that's not 1. So I have a solution of x equals 1. With the domain restrictions, x cannot equal 5 or 0. I know these can be a little bit tricky, so if you've got questions or concerns, please ask. I don't want you to be confused about anything. So if you do have any questions or concerns, ask during Zoom, send me an email or a Canvas message, but make sure you are asking any questions that you have. The rest of the worksheet, which are all review problems, will be part of